This is a review of the law of cosines for trigonometry, section 5.2 in Długopolski version 3. Solve the triangle with the given information. Now why I know this is the law of cosines is we are not given an opposite pair. With beta we'd have to know b. With alpha for A and gamma for C, we don't know those. Furthermore, since we're only given one angle, we can't easily find another angle. So we are not in a situation where we have an opposite pair or that we can easily find an opposite pair. You might think we could find C with using A and C, find B with the Pythagorean theorem, but that only works for right triangles, and we're not guaranteed a right triangle here. So we use the law of cosines. Now the law of cosines is something you have to know. Specifically, A, C, we can find B. B squared equals A squared plus C squared minus 2AC cosine beta. The B and the beta will be the only ones that are not A and C throughout. Now since there's beta, we can find its opposite pair B with the law of cosines. We would then plug everything in. So B squared equals 12.20 squared plus 7.80 squared minus 2 times 12.20 times 7.80 times cosine of 63.5 degrees. Now when we work out the right side, we get B squared equals 124.7596 dot 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 dot. Now it's important that you are in degree mode since we're given beta in degrees, and furthermore since we have b squared we need to square root this. Don't square root 124.76 or anything like that. Square root the entire piece in your calculator, and when you do that you end up with b equals 11.17169. Now I'm going to 2 decimal places because our A and C are in 2 decimal places as well. But B goes a lot more, and in fact I'm going to make sure to store this. Now the reason why I want to do that is I'm going to need B. Now that I have B, I've created an opposite pair. So I could use the law of sines to finish the job. Or I could use the law of cosines to finish the job. That's up to you how you want to do this. I think I will use the law of sines on this problem. Now the law of sines gets in trouble when you find the largest angle. The largest angle is opposite the longest side. So alpha might be obtuse. In the law of sines that would not be as easy to find. But I guarantee you that gamma is not obtuse because C is the smallest side. So I'm going to find gamma with the law of sines using our new opposite pair beta and our newly found b. This gives me sine gamma equals C sine beta over b, and plugging in our information we get sine gamma equals 0.62495. I'm writing all of this down because it is important that you use B, the stored value for B, not this 11.17, which will be the final answer for B, but the full information for B. Don't use just 11.17. If you do, then you're not going to get this for sine gamma. Now taking arc sine of the answer and the entire answer, no approximation, we get gamma equals 38.67 or 38.7 degrees. I'm going to 1 decimal place here because our angle is to 1 decimal place. Okay, so we have A, C, B, so do something special to that, B. We have gamma. All that's left is alpha, and alpha is going to be easy because alpha plus beta plus gamma equals 180. Once you have 2 angles of a triangle, the third angle is very easy to find. So we would have alpha equaling 180 degrees minus gamma minus beta. Those in any order you want. This would be 180 degrees minus 63.5 degrees. Oh, then I did it opposite. Minus 38.7 degrees. So I messed up a little bit. Gamma is 38.7 and beta is the 63.5. But this doesn't matter the order. What matters is our final answer, and that gives us alpha equals 77.8 degrees. Now the answer in the key has 11.2 instead of 11.17. And I believe our rounding is more appropriate because of the information to the nearest hundredth. And they also didn't use the complete information, so they have approximations. They have 38.9 instead of 0.7, leaving this to be 77.6 instead of 77.8. This answer is actually more accurate than the key's answer, but they're also very close. If we had gone to the nearest tenth for B, we would get their alpha and gamma as they did. Okay, great. Solve the triangle with the given information, A, B, C. We are not given any angles, just three sides. The trouble with some triangles is you might have an acute and an obtuse triangle. In order to determine that, I always use law of cosines to find the longest, from the longest side, the opposite largest angle. That way I'll know if it's obtuse or not. So I'm going to go after gamma. The formula is cosine gamma equals a squared plus b squared minus c squared over 2ab. This is something to either memorize or to work out from the c squared form of the law of cosines. Now I'm using law of cosines because since I have no angles, I have no opposite pairs to use law of sines. So we have cosine gamma, we plug in our information, and that gives us cosine gamma equaling. Now before I do this, I highly recommend parenthesing the numerator and the denominator so that the operations, the squares happen, the addition, subtraction all happen before this division, and all the multiplication happens before the division as well because of the parentheses, forcing order of operations. So we get cosine gamma equaling negative 0.19-ish. Taking arc cosine, we get gamma in degree mode, and arc cosine of the entire answer, 100.97. So let's go to gamma equals 101.0 degrees. So this is an obtuse triangle. That's fine. Now to find another angle, the next largest would be beta. We can find beta with the law of cosines, or we could find beta with the law of sines because we now have an opposite pair. The benefit of the law of sines is people usually find it easier. The benefit of the law of cosines is the law of sines would be using this value, and it's an approximation, not the exact answer. The law of cosines uses the given information. So I'm going to use law of cosines to make sure I have full precision. I'm going to go after beta now. Cosine of beta equals a squared plus c squared minus b squared over 2ac. The pattern, when you're after beta, you have a minus b squared. And everything else is a squareds and c squareds, a's and c's. When you're going after gamma, you have a minus c squared. If you're going after alpha, you'd have a minus a squared. That helps set these up. All right, this gives us cosine of beta equaling 0.564-ish, and so beta arc cosine the entire answer, and we have 55.59, so 55.6 degrees. We can find alpha in a couple of ways. This book, well, depending on your book, You can find alpha using another law of cosines. You could also find alpha with 180 minus gamma minus beta. If you do it both ways, then you can verify all of this work. It's not a bad idea. I'm going to find it with alpha equals 180 degrees minus beta minus gamma. That will give me 180 degrees minus 55.6 degrees minus 101.0 degrees. Finally, not beta, sorry, alpha equals 23.4 degrees. These answers match up with the key. Great. Determine the number of triangles with the given parts. There are no opposite pairs, no angles, so no law of sines. So this is a law of cosines problem. When dealing with the law of cosines, I always go after the possible obtuse angle. That would be the opposite of the A, because A is the largest. So I'm going to go after alpha with cosine alpha equals, setting these up, it'll have a minus a squared, because the alpha and the a are the opposite pairs. So b squared plus c squared and 2bc. Plugging our information in for BCA, we end up with cosine alpha equaling 0.223-ish. That's enough information, but if we do arc cosine of the answer, it gives us 77.08 or 77.1 degrees. One answer, and it's not obtuse. Okay, that's it. Really, the only thing you're looking for is if this number is larger than 1 or smaller than -1, it's not possible to find cosine equaling anything outside of -1 to +1. So if this number had been 1.2, we'd have no triangles. Given 3 sides, there are no 2 triangle cases. It's just 1 or none. And we got an answer, so 1 answer. Great. Determine the number of triangles. Now in this case, we have an opposite pair. So we should be able to use the law of sines. Using the law of sines, the missing piece would be beta, so we'd have sine beta over b equals sine gamma over c, which leads us to sine beta would equal b sine gamma over c. So sine beta would equal, now we've plugged this into our calculator, and we get 1.06-ish. There are no triangles because sine cannot equal anything over 1. And that's all there is to this. If you tried arc sine, beta would be an error. Now, if this number is less than 1, then you look for 2 possible cases. And we've already covered problems like this in previous sections. But in this case, there's no solution, so no triangles. Solve the problem. A ship travels 88 kilometers on a bearing of 15 degrees and then travels on a bearing of 105 degrees for 153 kilometers. Find the distance of the end of the trip from the starting point to the nearest kilometer. Now this is a little bit different bearing problem. Some books cover this, some do not. A bearing of 15 degrees, if they don't tell you it's north 15 degrees east or south 15 degrees east, then this is always based on north. So a bearing of 15 degrees is actually 15 degrees from north. A bearing of 105 degrees is 105 degrees from north. And next thing is you have to know that it's it's positive, it's clockwise. So we're starting here. 15 degrees means, let's see, I don't want to start there. I'm going to run out of room if I start there. I'll start in the middle. 15 degrees means from north, 15 degrees. Clockwise, that's the bearing of 15 degrees, and we go 88 kilometers. Okay, and then we go for a ways, and then 105 degrees Now 105 degrees again is based on north. 90, 105 would be about there. 105 degrees. Always based on north. That's what these bearings are. 153 degrees, so further. Almost double, or a little more than double. Less than double. That might be too long. And then find the distance. So we end up, find the distance. This is what we want to find. The distance. Alright. I put 153 degrees. I mean 153. So our triangle, we have two sides. Looking for the third side, but currently we don't have any angles. And that's not good. No angles at all. So we have to work a little bit to find the angle. One angle is all we need. We have two, we need three pieces of a triangle in order to solve the entire triangle. So this is now how we go. Very often, especially with bearing problems like this, we have parallel lines. That's the north-south direction. And we have a bisector. That bisector, opposite angles will be equal. So in other words, this 15 degrees will be the same as this 15 degrees. Alright, that helps. So let's put a little 15 degrees in there. Next, 105. The full north-south is 180 degrees, and if that much is 105, that leaves that much as 75. So that is 75 degrees. So we have the 15 degrees from a bisector of parallel lines, parallel bisector, and their opposites are equal. And then we have that this is a supplementary pair of angles. They add up to 180. 105 plus 75 is 180, or 180 minus 105 is 75. So we have these two pieces of this angle, 15 and 75. That adds up to 90. Wow, this is a right triangle. Okay, great. 90 degrees. So now let's draw this triangle a little more simply. It's a 90-degree angle. This is 88. This is 153, and we're looking for x. And because it's a 90-degree angle, and this is just totally random that it happened to be 90 degrees, we can use Pythagorean theorem. We could also do the law of cosines. We don't have an opposite pair. We call this A, call this B, we're looking for C, and we have gamma. So we could do a law of cosines. It's interesting, I want to do this time. We'd have c squared equals a squared plus b squared minus 2ab cosine gamma. When we plug this stuff in, notice a squared plus b squared minus 2ab. What gamma is 90 degrees. And what is cosine of 90 degrees? Why, it's 0. So the law of cosines on a right triangle gives us Pythagorean theorem. How wonderful is that? It's always nice to see a well-known formula is a simplification of a more complex formula, so we can solve a lot more triangles with the law of cosines, and it simplifies to our basic Pythagorean theorem if it's a 90-degree angle. So this is actually the formula that always works for all triangles, assuming you have the appropriate pieces, i.e. not an opposite pair, but three pieces. And it gives us Pythagorean theorem. So let's work out our little Pythagorean theorem now. C squared equals 88 squared plus 153 squared. That is 31,153. And square rooting this gives us our answer 176.5. So let's go to 177 kilometers. Now the reason why I went to 177 kilometers is the instructions round to the nearest kilometer. So we have, they're 177 kilometers away from their starting point. That completes this problem. Two boats leave a dock together, each traveling in a straight line. One boat travels 34 miles per hour and the other at 23 miles per hour. The angle between their courses measures 31.6 degrees. How far apart are they after 40 minutes? Well, right off the bat, I don't like this 40 minutes at all. This is miles per hour, hours. Everything's hours. So I would go right away to 40 minutes being 2/3 hours. That's the time I'm going to work with. Okay, so they leave a dock together, each in a straight line, and they are 31 degrees apart. 31.6, sorry. 31.6 degrees apart. Make that look a little better. Okay. And how far apart are they after 40 minutes? So let's say they run for 40 minutes and they end up here. And the question is, how far apart are they? Okay, one boat travels 34 miles an hour. So boat 1, distance equals rate times time. That would be 34 times, wow, my pen did not do well there. Let's try that again. 34 times 2/3, which gives us 22.66 repeating. That's the one traveling faster, so that'll be the longer side. 22.66 repeating. Okay, and boat 2, distance equals rate times time. That would be 23 times 2/3, and that is 15.33 repeating. And we now have a law of cosines problem. We do not have, oops, oh, it's not going to let me erase that. Oh well. Oh wow, perfect. We'll never do that again. We do not have an opposite pair. Whatever angle this is, its opposite would be this. That's what we're looking for. No opposite pairs anywhere. And we only have one angle, so we can't make a convenient other angle. So this is definitely a law of cosines problem. Now, let's call this alpha, that's A, that's B, so that's beta, and C, and that's gamma, just so that it looks more like our formulas. And that is totally up to you how you label those. Just make sure you have the opposite pairs in the opposite spots. Other than that, I don't care where you put the A's and the alphas in it, as long as they're opposite of each other. So in this case, we're looking for A. So we have A squared equals B squared plus C squared minus 2BC cosine alpha. And we have alpha, B, and C. So we plug this stuff in. A squared would be 15.33 repeat squared plus 22.66 repeat squared. And I'm actually going to type all this 3's and 6's into the calculator because I want to make sure this is correct. 15.33 times 22.66. Wow, I'm running out of room. Cosine of 31.6 degrees. Alright, thank you for different colors. It all works out. So A squared equals 156.844 stuff, and then we square root that, and we get our final answer, 12.5, rounded to the nearest tenth. I have 12.523, so I'm going to do 12.5, and we're in miles. That is how far they are apart after 40 minutes. Excellent.